Alright, so we're just going to do a couple of charge conversions to make sure we understand how to go from coulombs to number of electrons or protons, or from number of electrons or protons to coulombs. So let's start with this one. How many excess electrons are in -3 coulombs of charge? So since we know it's negative, that means we know we're going to have more electrons. So I'm going to say -3 coulombs. That's what we're starting with. And we need to get to electrons. So I'm going to say, okay, what is the charge of one electron? It's 1.6 times 10 to the -19 coulombs. So now I've lost coulombs. Those are going to cancel out. That's how many are in one electron. And so when I do that, I do 3 divided by 1.6 times 10 to the -19. And I always want to make sure I put this part in parentheses in my calculator, just to make sure that I'm dividing by that whole thing. When I do that, I get 1.875 times 10 to the 19. And that is how many electrons I have. And that is a big number, which makes sense because it takes a lot of electrons to make up that many coulombs of charge. The second thing, how many excess protons are in 2.4 nanocoulombs of charge? So this is where you want to think about, what does a nanocoulomb actually mean? What does it mean to be a nanocoulomb? And all that means is that I'm starting with 2.4 times 10 to the -9 coulombs of charge. So nanocoulomb means times 10 to the -9. That nano prefix means that. So again, I'm going to set this up. I know that I have 1.6 times 10 to the -19 coulombs. Now I have a positive charge. This is implied by not having a negative sign, so this is going to be positive. That means I have more protons. So I'm going to say that many coulombs are in one proton, because a proton and an electron have the same charge. And as a result, when I do that, I again take 2.4 times 10 to the -9 divided by 1.6 times 10 to the -19. And I get 1.5 times 10 to the 10th. And that, again, is a big number, which makes sense because I need a lot of protons to make up that much charge. The last question, what is the charge of an object with 3.4 times 10 to the 17 protons and 2.7 times 10 to the 16 electrons? Now what we have to figure out is, okay, how many extra charges do I have? The charged particles here are protons and electrons. So I'm looking at my exponent here, and I'm realizing that I'm going to have more protons than I have electrons by one magnitude of 10, about. So I'm going to say, okay, I've got 3.4 times 10 to the 17 protons. I'm going to subtract the number of electrons. And so that's going to tell me how many extra protons I have. So if I subtract those two numbers, .7 times 10 to the 16, I get 3.13 times 10 to the 17. So now I know that I've got 3.13 times 10 to the 17. There's that many more protons. I'm just going to label it with P+. Now I need to figure out a charge. So I'm going to say one proton has a charge of 1.6 times 10 to the -19 coulombs. And now I'm multiplying these numbers together to get my total overall charge. And when I do that, I should get a number that is 0.05008 coulombs. Boom. So that's converting between coulombs and protons, or vice versa. You want to make sure you know how to do these problems so that you know how to get the number of charge, or the charge value from electrons, or how to figure out how many electrons are moving when you know the charge value.